food boxes and containers and everything. And what they mean are they're lowering the health risk of your food. So high sodium diets, high trans fat diets, high cholesterol can all lead to heart disease. High cholesterol or calories can lead to obesity. So these things we're trying to limit in our food so we reduce the amount of risk to our health. Added preservatives or pesticides on non-organic foods are chemicals that are added to our food to make them more productive or make them have a longer shelf life. But those chemicals are really harmful to our bodies and are carcinogenic, so they can cause cancer. So we have these foods that have no added preservatives or organic because we want to reduce our risk of having cancer from the foods that we eat. So what this means is we're exposed to these things through our food. So we're knowingly eating these things that are causing cancer in our bodies. So we're trying to reduce that amount. But what about the things that we're exposed to that we don't know are harmful? Or we don't know we're exposed to them, but they're harmful to us? What about things like plastic? Plastic is in phone cases, water bottles, food containers, baby bottles, and we're exposed to them on a daily basis. But do we really know how harmful these things are to us? In many plastics, there's a chemical called BPA, or bisphenol A. And BPA is in polycarbonate plastics, which I said are in water bottles, food containers. And we're exposed to them through our diet. So we obviously don't eat plastic, but the BPA in the plastic leaches into our food and our water when they're heated. So like leaving your water bottle in the sun or like leaving it in the car, the BPA will leach into the water and then you drink it. So you might not think that's a big deal, but BPA is known to be an endocrine disruptor. So it messes with our endocrine system, our hormone system. So it messes up the natural functions of our body, and that can lead to very harmful effects. So now that I'm talking about hormones, when are hormones present in our body? Like all the time, but when are they most present? Does anybody know?
Like teenage adolescence?
Yeah, puberty. So there are 3 stages. The perinatal stage, which is the weeks before and after birth when you're developing into a person. During puberty, when you're going into a human, your body's developing, and pregnancy, when you're getting ready to have a baby. So during these times, your hormone system is working at overdrive. You're becoming more human, you're becoming older, you're developing breasts, your voice is changing, everything. So the paper that I'm looking at is called Pubertal Bisphenol A Exposure Alters Murine Mammary Stem Cell Function, Leading to Early Neoplasia in Regenerated Glands. Or also, how BPA exposure during puberty can lead to breast cancer in adulthood. So for the experiment, they looked only at female mice. There was a group that was exposed to BPA during puberty. So that's week 3 to week 6 in mice life. And then there was a control group that wasn't exposed to BPA at all. And then there was a DMBA cancer control. So the mice that were exposed to DMBA were not exposed to BPA, but they were given DMBA, which gives them cancer pretty much. So in the first experiment, they were looking at the cell production in the breast tissue. So they were looking at mammary stem cells, which are cells that will later on become breast tissue, so mammary glands and all that stuff. So you can see they looked at each week of or each stage of life in the mice right after exposure, which is right after puberty, and then later on in adulthood. And they were looking at how many mast cells, or these mammary stem cells, there were. And you can see in the red box, at 6 weeks, there was increased production of cells. There were more cells there than there were supposed to, compared in the BPA group compared to the control. So this means there was misregulation of our cell production, of the mice cell production. So in the next experiment, we know that there's misregulation of cell production, but how are these regenerating? How is it affecting the glands? What they did was they took fat pads. So breast tissue is made up of a lot of fatty tissue. So they took a fat pad and cleaned it off, so there weren't any mammary stem cells on it. And then they re-injected the fat pad into the mice and see what happens. So they were looking at the mammary gland regeneration, so how many glands regenerated on the fat pads. And you can see down here is their percentage of reproduction. Here, this is 76 to 100% is what we're looking at. That's really abnormal amounts of regeneration of glands. So that's also represented up here by the lightest color bar. And so the researchers stated that 2-month and 4-month information was not that significant. So we're not looking at that. We're just looking at the 6 weeks. And you can see at 6 weeks, there was more percent of lighter amount, more abnormal regeneration in the BPA group than the control group. So at 6 weeks, right after being exposed to BPA, the mice had more abnormal regeneration of the glands. So now they know that there's abnormal regeneration and there's increased cell production. What does that sound like to you? Increased production of cells and abnormal regeneration.
Cancer.
Exactly. So cancer, tumors. So then they were looking at tumors. So they were looking at the percent of hyperplasia, and hyperplasia is a tumor caused by the increased production of cells. So down here you can see there's a mammary gland in picture C, and you can see the gland in the center and then the layer of cells around the outside. And in D is a hyperplastic gland. So you can see the center of the gland, but then around it, there's not one layer of cells, there's many layers, so that's the overproduction. So in the graph, you can see that at every stage of life, at 6 weeks, 2 months, and 4 months, there was an increased production of cells. So that means at every stage, these mice that were exposed to BPA had more tumors than the control group. All right, so they know that now. They know now that BPA causes tumors. But how severe are these tumors? How severe are the cancers that BPA is contributing to? So they looked at ADH and DCIS, which they stated were very severe forms of cancer. And you can see down here the pictures. Again, you can see the normal mammary gland. And then in E and F is ADH and DCIS. You can't even see the gland. The cells have produced to such a great amount that the glands are completely covered. So, since they're very severe, you can see that it was only effective in adulthood. DCIS and ADH were the most productive, they were the most severe in adulthood, and even compared to the cancer control. So, in the mice that were given DMBA, so they were given cancer, the BPA had a greater effect, had a greater production of these severe forms of cancer than the cancer control. So this means that BPA has a huge contribution to cancer.
You might have mentioned this earlier, but did they use all female mice or was there all female?
It was all female. Any other questions? Okay. So now that they know that BPA does cause these severe forms of cancer, but how? Where did they go from here? They ran an RNA-seq, so they were looking at transcriptional changes that could have happened to cause these cancers. So, out of the thousands of different genes that they looked at, 40 of them were misregulated. And out of those 40, 9 of them were commonly misregulated by BPA and DMBA. And so they know that DMBA causes cancer. So those misregulated genes lead to the cancers that DMBA causes. So since BPA was also misregulating them, they can infer that BPA is causing those changes which cause the cancer. Does that make sense? All right. So that's where they can go. That's the future of looking into these things, is looking into where does DMBA actually act within your body and how does it make those changes to contribute to developing these severe forms of breast cancer. So in conclusion, exposure in mice to BPA during puberty contributed to them forming tumors and misregulating genes, which causes those severe forms of cancer. But if you listen to Project 80's podcast on BPA, they said that mice reacted to BPA a lot differently than humans did. humans were able to excrete it a lot quicker, so it might not affect us as much. So does this really apply to us? We really don't know. Anyway, you can take away from this that we live in a very synthetic world. We are exposed to plastic and so many other chemicals on a daily basis. In your lotions, shampoos, your chewing gum, like what are those things made out of? We really have no idea. So, what I always do is you think about what kinds of things you're coming in contact with. How can those things that you come in contact with every day be affecting your health in a way that you don't even know? So I want to thank you to Mr. D and Amanda Celli who helped me so much in this presentation, the Journal Club team, and all you people for coming every week. It's so awesome to be able to put on these presentations because science rocks.
Okay, so I know you're first time presenter.
Yeah.
But if you can't answer this, it's fine. So they talked a lot about how this is affecting female mice. Did they talk in like the mammary gland in females, and like in, I guess you could say, like pop culture, we hear only really about breast cancer in females. So how does this affect boys? Did it mention it at all?
No, they only looked into female mice, but I mean boys go through puberty as well. So maybe that could be something that they look into is how do they affect the males as well. But they didn't say.
Can you back to the slide with like the 15, 20? It was on the bottom with like the 4 pictures.
Oh, here.
Was that different mice showing different like levels of development, or was that the one mice that? Like what were those pictures showing?
Okay, so those are these are like the fat pads, and it's showing the percent amount of regenerated glands. So these are like the fat pad has more percentage of regeneration, so that was more abnormal than the rest. Can you explain why they clean them? Oh yeah, so they clean the fat pads to remove any mammary cells that were already on them, so it didn't affect their data because they were looking at how much was reproduced was regenerated after that. So if they had stuff already on there, it could affect the percent that they already had. They found later in the mice. Anything else?
Do you know if it said anywhere in the paper about how much BPA was given in relation to how much a human would consume on average from like a water bottle left in the sun? Like, are they getting a lot more of a higher dosage than one would just from their daily life?
They didn't say compared to humans, but I know they were given it directly into their stomachs, and we know that mice kind of react to it a lot different than humans will, so it kind of stayed there a lot longer than it would in a person. But I'm not sure exactly how it correlates.
Was there any acknowledgement of what we found in the podcast about BPAs? And if so, did they talk about any potential testing with other animal groups?
What do you mean?
So if mice have this very different dynamic with BPA than humans, perhaps we could try other mammals and see if there was a different...
They didn't say anything about that, but I think that would be a very good way to further research the effects of BPA. Thank you guys so much.